Imagine waking up tomorrow to a world without sunlight. Within hours, temperatures would begin to fall. Plants would stop producing food. Weather systems would collapse. Within days, most life on Earth would begin to struggle. Within months, our planet would become an icy, lifeless world drifting through space. The sun is so familiar that we often forget just how extraordinary it truly is. Every sunrise marks another day made possible by a giant sphere of burning plasma that has been shining for nearly 5 billion years. But where did the sun come from? How did it form? And why is it so perfectly suited to support life on Earth? This is the incredible story of the star that made our existence possible. Chapter 1. Before the Sun. About 4.6 billion years ago, there was no Earth, no moon, no planets, not even the sun. Instead, our region of the Milky Way was filled with an enormous cloud of gas and dust called a molecular cloud. Most of this cloud consisted of hydrogen, along with helium and tiny amounts of heavier elements forged inside ancient stars that had already lived and died. For millions of years, this cloud drifted silently through space. Then something changed. Perhaps a nearby supernova exploded, sending a powerful shock wave through the cloud. The disturbance caused gravity to take over. Slowly, the cloud began collapsing inward. As gravity squeezed more material together, the center became denser, hotter, and brighter. A new star was about to be born. Chapter 2. The Birth of Our Sun. As the collapsing cloud spun faster, most of its material collected at the center. Temperatures rose to millions of degrees. Eventually, the pressure became so immense that hydrogen atoms began fusing into helium. This process, known as nuclear fusion, released an unimaginable amount of energy. At that exact moment, our sun came to life. Fusion transformed the sun from a growing ball of gas into a stable star capable of shining for billions of years. Around the young sun, leftover dust and rock formed a spinning disk. Over time, tiny particles collided and stuck together. Pebbles became rocks. Rocks became planetesimals. Planetesimals became planets. One of them would eventually become Earth. Chapter 3. A Perfect Star. The universe contains hundreds of billions of stars, each with its own size, color, and lifespan. Some are tiny red dwarfs that burn slowly for trillions of years. Others are massive blue giants that live only a few million years before exploding. Our sun sits comfortably between these extremes. It is classified as a G-type main sequence star. It is stable, predictable, neither too large nor too small. This balance is incredibly important. If the sun were much larger, it would burn through its fuel far too quickly for complex life to evolve. If it were much smaller, Earth might never have received enough energy to support life as we know it. In many ways, our sun exists in a cosmic sweet spot. Chapter 4. The Engine Inside the Sun. Although we often picture the sun as a giant ball of fire, it isn't actually burning like wood or coal. Instead, it is powered by nuclear fusion. Every second, around 600 million tons of hydrogen are converted into helium deep inside its core. During this process, about 4 million tons of matter are transformed directly into pure energy according to Einstein's famous equation, E equals mc squared. That energy slowly travels outward through the sun. A single photon can take thousands, or even hundreds of thousands of years to reach the sun's surface. But once it escapes into space, it takes only about 8 minutes and 20 seconds to reach Earth. Every sunrise is powered by energy that began its journey deep inside the sun long before humans even existed. Chapter 5. The Star That Created Life. Without the sun, Earth would simply be another frozen rock. Its light powers photosynthesis, allowing plants to convert sunlight into food. Those plants feed animals. Animals support ecosystems. Entire food chains begin with sunlight. The sun also drives Earth's weather. It powers winds, creates rain, shapes oceans, controls climate. Even the oxygen we breathe exists because sunlight allows plants to produce it. Our biological clocks are synchronized with the daily cycle of daylight and darkness. Human civilization itself has always depended on the sun. Ancient farmers planted crops according to its seasons. Early sailors navigated using its position. Today, solar energy is becoming one of humanity's fastest-growing renewable power sources. Every aspect of our lives traces back to this remarkable star. Chapter 6. A dynamic giant. The sun may look calm from Earth, but it is incredibly active. Its surface constantly shifts with enormous magnetic fields. Dark patches called sunspots appear where magnetic activity temporarily cools the surface. Sometimes these magnetic fields suddenly snap. When they do, they unleash gigantic solar flares and powerful eruptions known as coronal mass ejections. These explosions send billions of tons of charged particles racing across the solar system. When they reach Earth, they interact with our planet's magnetic field. The result? One of nature's most beautiful displays, the northern and southern lights. These colorful curtains dancing across the night sky are direct reminders that the sun is alive with activity. However, powerful solar storms can also disrupt satellites, GPS systems, radio communications, and even electrical power grids. Despite being 150 million kilometers away, the sun still influences our technology every single day. Chapter 7. Our Future Under the Sun. The sun is currently about halfway through its life. Scientists estimate it has enough hydrogen fuel to continue shining for another 5 billion years. Eventually, that fuel will begin to run out. The sun's core will shrink. Its outer layers will expand dramatically. It will become a red giant. Mercury and Venus will almost certainly be swallowed. Earth's future is less certain, but even if it escapes being engulfed, our planet will become far too hot to support life. The oceans will evaporate. The atmosphere will disappear. Life, as we know it, will come to an end. Eventually, the sun will shed its outer layers into space, creating a beautiful glowing cloud known as a planetary nebula. At its center, only a dense white dwarf will remain, a tiny fading reminder of the star that once illuminated an entire solar system. Every moment of every day, the sun quietly sustains life on Earth. It has shaped our planet, powered evolution, guided civilizations, and continues to fuel the future of humanity. We often take its light for granted because it rises every morning without fail. Yet among the countless stars scattered across our galaxy, our sun is extraordinary. Not because it is the biggest or brightest, but because it gave us the chance to exist. The atoms in your body were forged in ancient stars. The energy that keeps you alive comes from our own. In every sunrise, we witness the same cosmic engine that has burned for billions of years. The story of the sun is, in many ways, the story of us. And tomorrow morning, when its light once again reaches Earth after an 8-minute journey across space, it will remind us that life itself depends on a single, remarkable star.